Okay, so I want to go and do a video just on chairs and chairs in general. So chairs are another way to write cyclohexane. It's a different conformation. It's like a different shape or form that a molecule takes in, that a molecule takes. So it's not a new molecule, it's a new way to look at an old molecule, okay? But there's some key pieces on a chair that we have to be aware of. Namely, um, what is on the chair and how you label it, but specifically for stability. Chairs are all about stability. And when you put stuff on a chair, a lot of the questions you're asked are geared towards what's more stable, what's least stable. So we have to figure out that when we're doing these questions. So here are the positions on a chair. They're called axial and equatorial. The axial is the red, and the axial goes straight up and down. Every carbon has an axial position, either up or down, depending on the carbon. If it's yellow, then it's equatorial. Equatorial is a slant, right? It's a slant up or down depending on the carbon. So this carbon here has axial up, equatorial down. This carbon here has axial down, equatorial up. Okay? But don't think axial, equatorial. Just think up and down. And understand that every pointy end like has a, so this one has one going up, one down, up, down. Every end of a carbon on, every carbon on a chair has an axial position, either going straight up or straight down. You do enough of these, you're not even have to worry about what's axial, what's equatorial. It's going to be second nature. So another rule is that when we're comparing structures, we want the bigger slash big groups equatorial if possible. Because when they're axial, you can imagine this. Let's say you have two parts of a chair, whatever. In the reality, when they're axial, the hydrogens can get in the way because they're kind of spread. They have their own little space, and so you don't want anything clogging up your molecule because we don't like sterics for a lot of these things. For stability, sterics is that the idea is it affects stability greatly. Basically, it's like, if is there stuff getting in the way, right? It's almost like if you would walk through a door, but that door had like two or three people trying to walk through it. It's a little harder to walk through it compared to if it was just you walking through a door. That's what chemicals prefer. They prefer it when it's easy for them. So when we're comparing stability, we want those big groups equatorial, because in reality, when they're equatorial, and it's hard to do this because I'm not physically here, but imagine like imagine this green line is over on top of this blue line. So they don't. So these groups here, if whatever's on them, they're not interacting with anything. So that's why we want equatorial, because in reality, it's just more stable. Then, now let's actually get into some problems. Okay, so I want to do this one. Trans 1-ethyl 3-methyl cyclohexane. We're going to turn it into a chair. We're going to flip the chair. Then we're going to turn that chair into a ring. The reason why we're turning the chair into a ring is because he could ask you a question about a chair, but it's in a ring. You got to be able to flip between the two. Okay, so let's do this. We have a couple important pieces. Trans 1-ethyl 3-methyl, telling us that one of these is up and the other one's down. Right? It doesn't matter the axial, equatorial. We're not thinking that. We're just thinking up and down because it depends on the carbons we put them on. Okay, we can put them on any carbon on a chair. I personally like to label the ends of my chair 1 and 4 because it makes it easier to flip it. Okay, so On 1, we have an ethyl. 3, we have a methyl. It doesn't matter. It's trans. I'm going to put the ethyl down. And then 3, I'm going to put the methyl up. Ethyl down, methyl up. Okay, so that's trans. If it was cis, it would be down, down, or up, up. Okay? I could have also put the ethyl up and the methyl down. Doesn't matter. I just want to do this. Cool. So we're going to flip it. When we flip it, this pointy end goes down, this pointy end goes up. AKA, hold on, I know it's a little messy. This ends up being this one. This ends up being this one, right? They just flip. This end flips down, this end flips up. Now, don't even worry about what the other things are, because there's a reason why there's a reason why I like to label 1 and 4, and I'm going to show you. When you flip the chair, now the chair is flipped, right? 1's down here, 4's up here. Okay, here's a rule. No, I can't write. Whatever's down stays down, whatever's up stays up. So what do I mean? On the first position, we have an ethyl going down. So we go to our new first position, and now we put our ethyl down. Notice that it went from equatorial to axial, okay? On our third position, we have a methyl going up. So we go, oh, hold on. Sorry, let's go back. My bad. Here's how we know where to put 3. It doesn't really matter. We can put 3 here or here. I just put it wherever. But it's important to know the IUPAC. Sorry, I totally ignored that. What I mean is that naming isn't very important for this one. So, according to IUPAC, we're gonna label it going this way, because that gives this guy the lower number. So, because we counted clockwise, we have to do the same thing for the flipped chair. We have to count clockwise. If you stick with the same direction and stick with these rules, whatever's down's down, whatever's up is up, and you just move 1 and 4, it should be straightforward. Okay, so we said 1 was down on the first position, now 1's going to stay down. 3 was up on the third position. Now on the third position, 3 is going to be up, but the only up position is equatorial. Okay, so now I want to ask another question. Which one's the most stable? Give it a pause and see if you can find it. Okay, so the most stable chair is actually going to be this one, because of this ethyl. Our bigger group is equatorial versus over this here, our bigger group is axial. We don't want that. So this first one, A, whatever, is going to be the most stable. Now let's turn A into a ring. And again, we have another little easy thing to memorize or to use. And to memorize. What's down on a chair is dashed on a ring. What's up on a chair is wedged on a ring. Number 1, I'll put 1 here, doesn't matter. It is down, so it is dashed. We dash it. Number 3, it's down, so we dash it. There it is. If we were turning this one into a ring, 1 is down, so it's dashed. 3 is up, so it's wedged. There it is. Now you should be able to flip between these two very easily as the questions ask. Oh, and that's it. Let me see if there's anything else I wanted to go through. Yep, that's it. So yeah, chairs aren't that bad. You just have to have a game plan. Every concept has a game plan, a strategy. You have a strategy and a plan of attack. It's not bad at all.